I first started learning about Elixir and learning about the Beam, I got this idea somewhere that you could have a cluster of nodes that would cross continents. And I'd seen that and as a demo of like, this actually works. And I thought, man, that is so cool. I have no idea how to actually do that. And that's really the problem, is it becomes an operations problem. It's not a problem that Elixir can't do it. It's operations, it's networking, it's data centers, and how do I cross-connect things? So I forced myself to think smaller, to put my ideas into a box, and I'm just gonna, the US East Virginia box, right? Like, just kind of limit it. But there's this quote from Joe Armstrong, who's one of the creators of Erlang and the Beam. He says, "I have this idea in which we'll connect all the world's Erlang systems to each other. Imagine if every process could talk to every other process worldwide." And you see, Joe was thinking, what if? What if we could connect all these things? What could we do then? And we could bring ourselves out of the little boxes that we've kind of limited ourselves to. And really, I don't know what we could do then. It really kind of takes the lid off, and lots of things become possible. So I'm going to start small. We're going to start and just address some of the most common problems that you have when you try to go multi-region. And so that's what we're going to cover. So we're going to talk about going global on fly.io and taking your Phoenix app, which is using a Postgres database, and going multi-region. My name is Mark Ericksen. I work at Fly, and I'm also a host on the Thinking Elixir podcast. So there are 3 problems we have to address. And I guess they're not so much problems as they are constraints. And the first one is we're going to talk about an ordinary Phoenix app. And that's just a constraint. It's not a problem. And we'll define what that means more in a second. And then number 2, the speed of light. That is a constraint, and we have to be able to deal with that. And number 3 is Postgres as our database. So Postgres was never created to be a multi-master, eventually consistent database. So we'll talk about how our apps can still go global while using Postgres. And so we'll talk about replicas, how replicas help solve some problems but introduce other problems, and then how to solve those problems. So first, let's come back to our ordinary Phoenix app. So when we talk about ordinary Phoenix app, we're saying you're using a regular Ecto repo, you're using Postgres, you have contexts, and it's a read-heavy app. So this is your traditional SaaS style app where your user is navigating around, clicking things, maybe toggle the state of something, maybe edit something, but most of their actions with your app are read operations. So that's where this works really well. But I think that's most apps. And I'm hoping that your app that is using LiveView, because this works really well when you talk about LiveView. As Chris was talking about in there, LiveView, when you get close to the users, becomes super awesome. But specifically, we're talking about an app that was not designed for being multi-region. This was something that I wrote on my own laptop with a single machine, my dev machine, and like the code that works on my dev machine, that's what I want to be able to take global. So that's the goal. Go global with an ordinary Phoenix app that I don't have to rewrite. Honestly, I think that's like the holy grail. Because how everyone else does it is they have to re-engineer. You have to engineer for that from the beginning, or re-engineer everything. So the benchmark we're going to use is ordinary code. Everyone has code like this in your app. I'm doing an insert, and then I'm turning around and doing a read. The problem is this actually doesn't work when you go multi-region. And we'll cover why that doesn't work and what we can do about it. But that's the goal. That's our benchmark, is to see, can we make this ordinary code work? So now we're going to talk about the speed of light. So here's the speeds in meters per second, miles per second. The point is, distance actually matters. So for the distance that we're going to talk about for the sake of this demo, we're talking about Los Angeles to Sydney, Australia. That's 7,400 miles, 12,000 kilometers. And that's what we're going to be talking about. And so if I wanted to take a flight from Los Angeles to Sydney, I would be on an airplane, a direct flight for 15 and a half hours. And that's about the worst case I could think of. But we're actually in Austin, which is a little further east, so it's actually over 8,000 miles. So we're now actually worst case, more so than what I built this for. But what we want to talk about is that 12,000 kilometers requires light 40.2 milliseconds to travel. So like if light was traveling in a straight line, that's how long it would take just to travel that distance. And that's the theoretical fastest time. So the world isn't ideal, right? The electrical signals traveling through the wires or the fiber optic cables aren't taking a straight line. They're going through some other path. And there are routers along all these different hops where the packets have to be inspected and then forwarded on to another route. So we know it's going to be slower than the theoretical minimum. So it will take longer. And we're also having to deal with network congestion, dropped packets, and retries. So just thinking about the multiple trips is where it becomes a real deal killer, where it takes 40.2 milliseconds to make a request and get a response takes 40.2 milliseconds and back and forth. Just doing that, just in transfer time alone, is 160 milliseconds added. And that's the ideal, right? And we don't even have the ideal. So if I did a ping time from my server in LAX to my server in Sydney, I'm getting 148 milliseconds. So that's like realistically the distance that I am between my two servers are. So how do big companies deal with the speed of light? You got Netflix, Xbox with live gaming, Cloudflare. The way they do it is they actually move the servers closer to the users. They just shorten the distance. They don't fight it. They don't fight the speed of light. So, but that's where it gets really hard, right? Because then you start dealing with multiple regions, multiple data centers. How do I bridge and keep it secure? How do I do that? Honestly, as a solo developer or a small team developer, I have no idea. It is an impossibility for me. The big guys can do it. Google, Amazon, I don't know how. They have huge engineering teams. But I want to be able to play with the big boys and girls too. And I think we all often would take a look at that problem and just say, well, I guess I can't play with those guys. But our solution can be their solution too. We can deploy close to our users. And Fly.io makes that really easy. So Fly has regions. And right now there's about 20 available. And you say, I want to add a region using the command line interface. And this adds LAX, which is Los Angeles. And then you can add MAA, Chennai, India, or SCL for Santiago, Chile. And then you just scale your app to put instances in those regions. So what happens when we actually scale and we have multiple nodes now? So this is the internal network. Within Fly, I have my app in LA and my app in Sydney, and there's a WireGuard tunnel that's put up between the two. And WireGuard, Chris mentioned it, it is a new cutting-edge VPN replacement, but it's so much better than any VPN you've ever used. It's built into the Linux kernel. It's on all your iOS, Android, Windows, everything. And so it is like the replacement, the way to do things. And so Fly is automatically creating a VPN network for you between your nodes. So they already have secure, direct pathway to each other. And you won't be able to see anything else on Fly. So you're already boxed to just your apps, and no one else can see your apps. Just getting to that point, I never could get that far, like with AWS or anything. And so from the external part of the network, how do my users get anywhere. So there's a standard called Anycast DNS. And when a user tries to go to my website, Anycast figures out which of my fly regions is closest to them and will send them to that one. So if I have customers in LAX, but I'm running everything out of Sydney, they will be directed to the LAX one. Or if I have customers I'm adding in England, I can add something close to them. And really, that's where LiveView starts to shine, right? So much people kind of complain, oh, LiveView can't actually work because speed of light. They actually say that. And it's like, no, well, okay, maybe that's the case for you and your app. But if you just bring it close to the users, then, man, it is snapping. It's popped. It's wonderful. So now we're coming to Postgres. And really, that is the main bulk of this talk, and the problem is how we deal with Postgres here. Because if my app is close to my users, but my database is still really far away, it doesn't actually help anything. So let me walk you through the path that I took on this. So coming back to this distance, my primary database is in Sydney, Australia. I did this to punish myself. I wanted to see, what do our poor brothers and sisters down under deal with when they're visiting my website and your website in Virginia? And so I deployed the primary there and then created a LAX, happens to be the closest fly region to where I live in Utah. But if I do just that and I deploy my app, this is what it's going to look like. My app in LAX is going to have database connections that are connecting directly to my primary, which is across the ocean in Sydney. So that's really not ideal, right? Because I'm having a lot, we know what kills us is the back and forth. And when the code that I wrote in my app did not account for my database being far away from me, right? My code makes the assumption that my database is 0 to 2 milliseconds away from me. And so what Fly provides here is multi-region Postgres SQL. So there's 2 steps to adding a replica. So the first is just adding a volume in the region where you want it to be, and you choose the size of the volume, 10 gigabytes. And then you scale your database app to say, I want to have 2. And that will be, so if LAX is my second region, then scaling it to 2 will put a database app in LAX. And now I have a read replica. So now that means my app in LAX has direct database connections to the replica that's right next to it, okay? And so now it's super fast, all the reads are really smooth, but the question is obviously well, how do I do writes? One thing I do want to mention though, replication. When you add that replica, Fly automatically sets up the replication and does all of that for you, so you don't have to, there's nothing to manage, which is super helpful. So the question now is, how do I do writes? So the default way I thought, well, I took this approach on my test, and I said, well, I'm just going to have my LAX app have open connections to the primary, so it can talk to the primary when it needs to. But that requires changes to my app in a significant way. I have to add 2 repos, one that does read-only and one that does writes, and now my code has to know which one to use. And that's where I start to not have an ordinary app anymore, right? It starts to get more complicated. And then it doesn't scale well, because as I add more regions, I just have all of these open database connections to my primary. And that's really not great. But that's not even the real problem. The real problem is read your writes consistency. And it's because the replication process is asynchronous. We don't know when that's going to happen, and we don't know when it's going to be done. So it's a background process. That's the real problem. So what that means, let's walk through it. When I do a write to my primary, and then my next line of code says, now read from my app, it says, oh, well, I'll go and I do reads from the replica. So I do my write over there, I insert some data in my primary, I turn around and read it, and my database says, I don't have that record. Or I do an update and I'd say change this email address and say I have the old one. Or I delete this record, it's still here. Your user starts to not like that, right? It feels like something's wrong and they have to hit refresh to see the stuff as it happens. It's because replication is happening back here. And the main thing is we don't know when it's going to happen. Sometimes it'll happen, it'll replicate before your read action and it'll work fine. And sometimes it won't. It's just the fact that we can't count on it. And now this is a truth for any read replica you have. If you have your own hardware, you're hosting everything in your own data center, and you have your primary and your replica sitting right next to each other, this same condition exists. This is just a problem with having read replicas. So let's kind of check in on our goal. This is our goal is to make this code work. And we know that if I insert an order, I can't count on being able to read it. So we're not there yet. So maybe there's another way, right? We're using Elixir. We can do things like, Chris was talking about. We can do things that other environments and frameworks and languages really can't do as well. So let's try something different. Let's say I actually want to, instead of talking to the database, I'm shifting the layer at which I'm talking to, and I'm going to switch and talk to my app instead. And I can RPC, because Elixir makes RPC to run node.spawn, where you say run this function on that other node. That's so awesome. It just works. And so I can just talk to my app, have my app do the write. Okay, well, that doesn't actually fix our problem yet. We're not there yet, but we've changed the layer at which we're doing the discussion and having the talk. So we still have to solve the replication problem. Let's do that. So this is where Postgres is really, it's a cool database. I love Postgres. It really is my favorite. And that's why I want to keep using it, right? And so Postgres has two functions in it that are really important here. And the PG current WAL insert LSN and PG last WAL replay LSN. So WAL is write ahead log, and LSN is a log sequence number. So what happens is the insert one is after I've made a change to my database, I can ask Postgres, it's already keeping a log of all the changes that are happening. And it creates a sequence number for where it is in that process of those changes. I can just say, after I made a change to my database, what is the log sequence number for where you are now? And then on the replay side, I can go to the replica. And I can say, you're applying all these changes. Where are you now in what's been applied? So we need to make sure we can trust the WAL. So we're kind of talk it through a little bit. So the primary and the replica are connected through the replication. The replication process is a stream of data. It's sequential. It has to be applied in order. So we know it can be counted on to be sequential. And so when an insert happens, where we talked about that, I made a change. That insert flows down to the replica through this whole stream. And I am able to, that second call, I can ask the replica, where are you now in the log that has been applied? And don't worry about having to track like IDs, right? We're not talking about like user IDs. We're not talking about transaction IDs. It's a sequential number. And that's the power of this, is that they're comparable, these LSNs. I can say, is this LSN greater than or equal to this LSN? And that just tells me, where am I in this log stream? Have I gotten to at least this point in this log stream? And if I have, then I know the data that I care about has been replicated. And also don't worry about having to wait for replication to all settle down, right? We're not waiting for all the changes to settle out. They can all be going on concurrently. So I can have the insert I care about, and a bunch of other inserts are happening before and after it, and there's still changes happening actively. And I just care about, when has the point that I care about in the log reached the replica? So now back to the RPC. If I can talk to my app and have my app do the write for me, then it can ask and say, what is the insert LSN for after this change has been made? And it can pass that back through the RPC call. So now on the app in my replica region, in my far away distant place, I can say, I know the point in the replication log that I care about to have my data, my change. And that means we can wait for replication. This is it, guys. We have arrived. Okay? And it's kind of anticlimactic as a slide, right? But but this is it. And so the way this works, we'll just kind of talk it through. So our insert in LAX goes to Sydney, goes to the primary database, but we can have library code that can say, well, I'm going to take the RPC result, which has the LSN number that I care about, and I'm going to talk to a service that's running here on my replica, and it's just polling the replica constantly, and I can say, hey, tell me once the data that this LSN represents, once that's replicated, just tell me when it's done, and I'll just sit here and wait. And so I'm able to create a blocking insert. So the insert can sit there and execute, the data gets inserted far away and replicated locally, and now I'll continue on to the next line with my read. So my data will be there. Chink. I can actually read my writes. Now, obviously, you'll be saying, well, my repo doesn't do that. And it's true. So we created a library called fly_Postgres. So the idea with this is you take your existing repo and you just move it out of the way. In this case, I gave it a .local name. So just change the namespace. And then I created a new repo that had the same name as the one in my app, and it does a use fly repo. And the local repo is pointing to the actual ecto repo. And so the job of the fly repo is it proxies those calls. It says you're doing an update, an insert, or a delete. I know how to proxy them. I know what the regions are. I know how to find the app, your app running in a different region. The main reason of kind of moving the ecto repo out of the way is so none of your code has to change. All of your references to your ecto.repo, your my app repo, all stay the same. So ordinary code, business logic code, does not need to change. You want to see it? Let's see if it actually works. Because, you saw how the demo gods were not kind. Okay, let me get a mouse. All right. So this app is running in Dallas. This is nice and close. And my primary app is running in Sydney, Australia. So let's see if this will work. So first, you can see, so this is a LiveView app, right? So you can see conference Wi-Fi accepted. It's still darn snappy, right? And so that's LiveView. It's not the new stuff that Chris was showing off with the modals that happen locally. This is all server-rendered modals. And if I type something, remove it, I'm getting instant feedback, right? And now when I actually go to do a record insert, let's see. Okay, I didn't see any lag, did you? No. All right, what happens if I edit this guy? Okay, there's a little bit of lag. Did you see that? I'm totally okay with that. And what if I do a delete? So, I just love how snappy that is. It's even better when you're not on conference Wi-Fi. But when I delete, there's a little bit of a lag, right? We see that we still have to deal with the speed of light and the speed of replication. But that's so much better. So it works really well for a read-heavy app, which most SaaS apps are. Okay, so that's just simple insert, update, and delete. What about something more complicated, right? So here's this feature called a quick add, where it's a LiveView managed list of IDs, and I can create a bunch of templates from these. I can actually create records from this, and there's quite a few. And So that's what we're going to be talking about. So let's look at the code that sits behind that. Okay, so this is the non-optimized code approach. This is a LiveView application that has an event, and it says I'm going to take a list of all those IDs for the different templates that we want to create. And like the third line, we see it's just an enum each. We're just going to go through each one of these, say create it, actually go create this location. So I didn't change any business logic, right? This is what happens. And so it's going to create a location, and it's going to, so we know that my proxy is going to sit in there and proxy the inserts. So it's going to insert, wait for data replication, and then do the second insert and wait for data replication. And you can start to see that's going to be really slow, right? You can already tell. And then it makes it even worse, right? Because after that, we're going to fetch all the locations that were added, and we're going to, they come out in an implied order. So we want to make that order explicit so it's reproducible. So then we'll do an update on each one of them to set their explicit position. So, because it's a draggable list. So let's see how terrible that is. Okay, so now we know what we're going to see. So here's where I'm going to add all. I'm going to do it nice and do it that way. So it's actually going, right? And we know we're doing this, it's the whole multi-round trip problem, right? We're doing insert, wait for data replication, insert, wait for data replication. Okay, they all came in. So first of all, yay, it worked, but you know, like that's suboptimal, right? I don't like that. And so how can we deal with that? All right, so with the refactor, what I'm going to do is just take all of the business logic that was in my LiveView event and extract that out into a function that can be called, just needs to be addressable, just needs to be a public function. And then I just change the return type so that I'm not returning my whole list of locations because that's an arbitrarily large list. I don't know how big that could be. That's message passing really far. And I'm already waiting for the data to come through my database replication. So I don't really need to return that to bring the data twice over. And then I'm going to handle the event. I just extract, so I've already extracted that code out. I'm just going to say RPC and wait in this same module. I just pulled it out. Call this function passing these arguments. And I'm going to wait for it to make the call over to Sydney, have Sydney, because it's close to the database, do all of the work. It can do all of the normal reads, updates, reads, and updates, and do everything, and then wait for it to finish and replicate before I go on to my next line, which says, okay, I know my data is here, fetch my list of locations, and so I can continue with my render. All right, let's see if we are able to get a look at that. So if I select them all, it is quite a list. And so this is doing the RPC all the way over. There's still a lag, right? But that was darn fast. We're doing all the work over there, letting it do all the normal business logic we already had. So let's see that one more time. So you can see this could be better, right? We could add maybe a little spinner or something to say, hey, we are doing something, we are working. But like that works. So when do I want to do an explicit RPC? So when we have slow performance like we saw there, when I'm doing explicit start transactions or transaction management, using ecto multi is one of those cases where it's doing explicit transaction stuff. If I have lots of sets of reads and updates where it's the back and forth. Background jobs. Lots of times background jobs make the assumption that they're doing some work and updating the database. So those probably should happen in the primary region. There are other background jobs that might be sending emails where it doesn't matter. So I checked with the Oben project, and they have queue splitting where you can say, you can give it say if I am in the primary region, run these jobs. And so you can totally do something like that too. So to do all of this, we created 2 Elixir libraries. So Fly RPC adds region awareness, Fly region awareness to your app. And it lets you easily RPC to another region. Not just a node, but like I could have 6 nodes in that region. I just send this over to that region. And then Fly Postgres, as it's using the RPC, it tracks the replication process with the LSNs. And it does where I can, at my LiveView process can say, tell me when this is done and it has replicated. And it defines the Fly repo that does the proxy. So both of these libraries are pretty early days, right? So we'd love to have people use it and give feedback. I know I already got some feedback. Someone was trying to use it with the ACE framework. And so we're missing some repo calls. So there's stuff to do, but you can see it's working. So what I think is awesome, though, is when we look at who is providing what benefits. So Fly is providing a lot of that operational infrastructure stuff. The global deployments, the multi-region networking, the multi-region Postgres replicas that are already set up and I don't have to manage them. And Elixir is bringing some really powerful stuff to this equation, which is the built-in clustering, so I can have my node clustered. I have concurrency, I have processes, so that I can have a blocking process like an insert that doesn't freeze the whole app, right? That's so cool. And I have message passing, I have ETS tables, which keep things all fast and smooth. So one of the things to just be aware of is most Elixir systems can't easily do this on other platforms. And most other languages and frameworks like Node, Django, Rails, they can't take advantage of what Fly is doing because they don't have clustering, they don't have concurrency, they don't have processes. They can't do the LSN wait, right? Because they're just not able to. So it really does feel like Elixir and Fly were like made for each other. I love it. So we've covered everything. And just coming back to Joe Armstrong's talk where he was thinking, what could happen if? So I want to encourage you to climb out of the mental box that you've kind of been limiting your ideas to. I don't know what ideas and things you'll come up with, but I can't wait to hear about it. And this approach, following this, just means that I don't have to rewrite my app. I don't have to relearn how to work with different kind of database or how to work with eventually consistent data. I don't have to do any of that today to be able to start going global now, right? I can do this with my ordinary Phoenix app that I know you have sitting on your laptop, probably 6 of them, right? And once your app has gone global, what could you do then? What kind of problems could you solve for your customer? You've got that idea for that app, and you think, well, you know, I'm a solo developer. I think I could at least target and hit all of the English-speaking countries, right? Without having to do internationalization. Well, now you can. So it's time to play. Have fun. Thank you. We have time for questions. John?
Yeah, so Mark, I was going to ask, and I don't have a lot of like DevOps experience or anything, so or even like this level of stuff. But what could an optimistic style like I know we have like optimistic updating with like JavaScript front ends. Could something like that work for this read-write problem?
Yeah, it just complicates your app. Because your app says, well, I have to insert it. So then you're saying, I can't write normal code, right? I have to insert it into my list because it might come in later. If there was a problem with the insert and it failed like for a uniqueness check that happens at the database, then how do I show that to the user? You know, it just complicates it.
But what if it was at the level of like ETC or something, where you're doing the optimistic, like here's a buffer between my
Yeah, then you're doing multi-master almost, because you're talking directly and inserting to your ETS local that has to be replicated and avoid conflicts. So it's tough. Yeah.
I'm curious about, do you guys like have your own servers that you build your own data centers, or are you guys utilizing the existing cloud, AWS, Google Cloud?
Yeah, so we use a lot of different, so we don't build our own data centers. So we're using other people's data centers. We have some DigitalOcean, some AWS, some stuff that's in Germany, that's not one of those. So you have, it's lots of other data centers we're using those, yeah, but able to already do the WireGuard connection to give you the private network across those. You don't actually have to care about where your actual app is.
So how do you guys manage your pricing structure to like stay competitive if you're still having to pay those underlying costs?
Good question. I don't know. Yeah, the pricing is really good. You can do, so you get so like if you sign up for the free tier, well, if you sign up and want to get as much as you can for free, right? You can get 3 apps. So one app is your database, and one app is your app. So if you want to go multi-region and have read replicas, then you do need to have 4 apps, because you'd need to have a read replica app for your database and your primary database, and then your app that's close to the read replica and your app that's close to the primary. So you'd end up with 4. But yeah, most of Fly's customers don't end up actually hitting a bill. Only about 25% of them do. So like you can, if you want to just like start experimenting and play, yeah, you can do that for free.
Does the Fly Postgres library allow you to choose if you want to wait for replication or not?
Not yet.
Always proxies and always waits for replication.
That is the default, right? Because that is makes it work. But yeah, we do want, I do need to add the ability to say, this one I don't care.
An insert non-block or whatever?
Yeah.
All right, one more. Do you guys have any plans to kind of expand which databases you support and kind of introduce this across those?
So I know, like Kurt is the CEO at Fly, and he's a very technical founder. And one of the things he's really excited about is databases like CockroachDB, which is a Postgres compliant query structure, but it is multi-master and replicating. So it doesn't do all the things that maybe a Phoenix app might want right now, but it's like, hey, there are directions we can go in the future, and you can run a CockroachDB, and there's another one that's similar, but I can't remember the name of it. But there are other options, but Postgres is the default one.
Does the Fly RPC library require like setting up libcluster or any other?
Yes. So assuming you've already set up a cluster. So I wrote the guide on Fly for setting up, getting your Elixir app deployed and clustering it. So I can tell you, clustering is actually really, really easy. There is a DNS strategy, so libcluster DNS strategy that was added that Kurt actually created. He's he's a very technical co-founder, or founder, yeah. And so he wrote the first Elixir library, so it will cluster, makes it so libcluster can work with Fly, and it's using DNS as the way it can find your other apps. But yeah, so clustering, you do have to have clustering in order to do RPC, yeah.
So clustering's heartbeat can struggle when there's long latency. Have there been apps in production that show that that's not much of an issue for worldwide deployments here?
I haven't seen it, but like this is, when I say we're early, like we're early, right? Like this is, I haven't, even before this library, there wasn't a good way that I could do a Postgres database that was far away. But yeah, it's totally worth continuing to explore. Yeah. Is there a reason why we're polling versus streaming the Postgres log? That was, so the polling one, there's a function that was already available for just doing that. I would like to look into reading the stream and see what's, part of what we're trying to do is what can I do that doesn't require special permissions? And So that's a good question, though. Any other questions? Yeah.
I was curious if it's kind of like a death by 1,000 cuts. They're doing all this polling operations at the same time, but that causes issues at scale. It's probably not expensive, but
Yeah, it's a very cheap, because it's a built-in function to Postgres. But yeah, right now I have it set to poll every 100 milliseconds, but that could totally be tuned.
another question is like, do the regions know how far apart they are and assume a certain delay before they even start trying?
Right, yep, so, not yet. Any other questions? Cody?
Does the fly RPC lib work outside of fly?
It totally could. And really, what I should stress about these libraries is they're really small. And so you could just like take that code and just like run that anywhere you have. Yeah, so it does add some regional awareness, but if you had some way to identify that these nodes belong to some group, then it would just totally work. Yeah. All right, well, thank you guys.